All right, let's get into the next part of dealing with theoretical probability. We're going to be looking at some key, well, they're the key vocab that go along with being able to calculate probabilities. And then there's some notation that goes with that. So let's zoom this in a little bit here. This is what you guys are going to be working with. And what we want to look at is what an event is, sample space, and then the trial, also called the probability experiment. So when we work with an event, we are talking about anything that can occur. So maybe an event is rolling a die. So when you roll a die, you have outcomes that come from that. And the possible outcomes from rolling the die is what is called the sample space. So those possible outcomes being 1 through 6. And then when you say, want to find out, hey, what are my chances of rolling, a 2? Well, for you to figure that out, you would do a trial. So a trial is actually doing the event, rolling the die, and then seeing what happens. And then we have this N of A, N of U, and then P of A. And we'll talk more about that here in a minute. So first of all, let's just give a little bit of definition here. So an event is an occurrence. We'll just go with it that way. That is the working man's definition. Your sample space is all possible outcomes. And then your experimental probability experiment, your trial is doing the occurrence or the event. So I won't write that in there, but that pretty much should make sense. All right, so N of A means, so A is your event. So let's just define that. A is the event. And so when we say N of A means the number. The number of times, say, the outcome happens. So that's the number of times the event takes place. And then N of U is going to be the number of all possible outcomes. So N of U, U is all the outcomes. So N of U is number of all outcomes. Okay. So if we want to calculate the probability of A, and that's what this P of A would mean, that is the probability of your event taking place. And so if we wanted to do, let's just say it this way, of A or event. So the probability of your event, like I just said, what's the chances? What's the probability of rolling a 2? Well, how many 2s are there on a number cube? Well, there's 1. So there's one possibility. So that would be the N of A. I'm not saying the actual number 2 goes in there. That doesn't make any sense. So the number of 2s that could possibly happen is 1. There's 1 2 on that cube when you roll it. And then what are all the possible outcomes? Well, it's 1 2 3 4 5 and 6. So the probability of being able to roll, oops, sorry about that. Let's see if that clicks off. There we go. The probability of rolling a 2, we would use this formula. So calculating that formula, what is the probability of our event? The number in our number of possible outcomes is 1. Number of all outcomes is 6. Okay. So your processing here is pretty straightforward and simple, not any different than what you've done when you've calculated probabilities before. So I think in definition, when you were younger looking at probabilities, it said, what are the number of, what's the term? Not the number of possible outcomes, but the number of favorable outcomes. There you go. So the number of favorable outcomes means that you rolled a 2. And so then the number of all possible outcomes was the bottom part whenever you looked at the standard or classic way of defining probability. Now we just do it in the sophisticated, because we're so much more sophisticated now, format. Okay, so here's a pretty straightforward question for you. What is the probability of drawing an ace out of standard deck of cards? Well, to be able to answer this, first of all, we need to know there are 52 possible cards. So n of the whole possible outcome is 52. Okay, and so we're talking about how many aces. Well, how many aces are in a deck of cards? Well, we have 4 aces. So if we have 4 aces, then we would say the number of our events drawing cards, the number of possible good events, favorable events, is the total number of aces, which is 4. So then we would say, well, what's the probability of A? And that's where we're going to go n of A divided by n of U. So there are 4 aces out of 52, which simplifies, I think, to 1/13th. And then you can turn that into a decimal, into a percentage. All right. All right, let's do one more. One more thing here. One other part of this is what's called your expected number. Now, the expected number, or expected, well, let's see how they say it in the book here. The expected number of occurrences, and that was one of our key terms up there. So the expected number of occurrences is actually calculated by taking your probability, and you're going to multiply that by the number of times it occurs. So n is the trials you would do to figure this out. So let's do it this way. Let's be a little more exact here. So in order for you to be able to calculate your expected numbers here, if you made 13 draws out of the deck, how many aces would you expect to draw? Well, what's the probability of drawing an ace? Well, the probability of drawing an ace, so the probability of we just calculated that. That was 1/13th. And then it says, well, what's the number of times you did that? Well, if you're drawing it 13 times, and this should make sense, the number of times n equaling the number of trials, the number of draws, in this case, that your event is drawing out. So the number of times you're doing this thing, this trial. So number of draws or number of trials. And in this case, it was 13. So 13 draws or number of trials. To find your expected number, you're going to multiply the probability of what you're doing times the number of times you do it, the number of trials. So our expected number in this case is going to be 1/13th times, we did it 13 times. So this should make sense. That results in 1. In other words, well, how many aces would you expect to draw? How many would you expect to draw is the question here. Well, it should make sense. If you drew 13 cards, you would expect at least 1 ace to show up. And by the way, that doesn't mean you're going to get an ace, and it doesn't mean you're only going to get 1 ace. We're talking about expected probability. So we're taking from this theoretical, and the theoretical would be, in this case, what's the probability of getting an ace if you made a draw? Well, it's 4 out of 52, which is 1/13th. So that's the theoretical pure probability. Okay, so from that is like, well, what's the expected number of aces you would get if you drew so many times? Well, in this case, we said 13 times. So if we draw 13 cards out of there, we would expect to get 1. But you could get more aces, obviously, or you could get no aces. So notice the difference there between theoretical, and then actually that's leading into this idea of experimental. All right, so hopefully I made that as unclear as possible, and now you're walking out of here from this video going, I don't know what the heck's going on. Well, you can watch this video and then actually go look at the book if that will help you. But this should give you some idea what's going on. All right, guys, We're going to do the second part to 8.1 in the next video, more about theoretical, going into experimental probability. See you in the next video.